All right, guys, we're going to add to our notebook again. This time we're going to be talking about how to graph linear equations. So in our table of contents here, we're going to put graphing linear equations. And this is going to go on 9 and 10. Okay. Now the kind of struggle here is for some of these notes, I didn't put them in the packet online. I printed out sort of like note cards for us because it's pretty important. I wanted it to be like an easy to find page. So I'm so sorry about that if we're at home and we don't have these. But we have these big old note cards here that we maybe don't have. So if you can kind of write down some notes about these while I go through them, that might be smart to do. And I can give you these when we come back. All righty. So you're going to want to make sure that you are paying close attention to the equations specifically. So when we are talking about graphing lines, there are kind of three main forms that a line can be in. And depending on the form that you're in, you're going to graph a different way. Now you can always change the form and make it look like a different thing, but that kind of wastes time because I'm having to do a lot of algebra to make it look like something else. And if I can save any time at all for something like an SAT or whatever, that's great, okay? So if we can keep them looking like they already are and not make any changes, that's really good to do. So the first form that we're going to talk about here is y equals mx plus b. This is probably the most common form. Probably a lot of your Algebra 1 teachers were obsessed with it. They talk about it all the time. It's kind of my second favorite form. It's fine. I like a different form a little better. But if you're in this form, I'm going to sneeze. It's going to be bad. Oh my goodness, I'm so sorry. Okay, back to it. If we are in y equals mx plus b, the reason your Algebra 1 teachers like it so much is because it's pretty straightforward and easy to graph. The first thing you want to identify is the number being added or subtracted. We are going to use that as our y-intercept. So this b number here is going to be our y-intercept. We're going to plot that first. If you don't see it, it's 0. After I have a starting point, then I just need to know how to travel. And so the thing that we use to travel is our slope. And so we're going to do that slope second, and we're going to think of it as rise over run. Okay, so our slope is always the number being multiplied to x like that. You always then want to take a step back and make sure, does my line make sense? Does this look right? Like if my slope was positive, does it look like it's a going up line? This form here has a name. It's called slope-intercept form. Okay, fancy math name. Makes sense because you can see the slope and you can see the y-intercept. Next form of a line. So again, that one's good. This one I like a little better. So this next one that I want to talk about is y equals a, parenthesis x minus h, end parenthesis plus k. You may have learned it when it looked like y minus y1 equals m parenthesis x minus x1. Like maybe that looks a little more familiar to you, or maybe even y equals m parenthesis x minus x1 plus y1, where we just kind of move the y over, which is essentially what I've done here, except for I changed the letters and kind of for sneaky reasons for later. But also kind of because I feel like the x1, y1 sometimes confuse people. The reason I like this form slightly better is because rather than having to have the y-intercept, which is one specific point on a line, this form of an equation allows me to use any point on the line, which is great. Like I don't have to know just one. I can know any point on the line at all. And so these pair of numbers right here, this is what I'm going to graph first as a point on the line, okay? It's important to note that h, the number inside the parentheses, will always come out oppositely, and that's because of that negative sign in front of it. Then, just like the last one, the number being multiplied, the number out front, is your slope, and so you'll do that second as rise over run. And then there you go. If you really want to, I mean, you could distribute and combine like terms and then just do y equals mx plus b, but you're trying to save time. You're trying to graph as quickly as possible to get your homework done as quick as possible. So there's that one. That's my fave. Oh, this one has a mathy name too. It's called point slope form. And that makes sense because it's got a point and it's got the slope. So there you go. The last form of a line, my least favorite form, most people's least favorite forms. It's just not super helpful. So ax plus by equals c is not super helpful because the numbers that will be in place of a, b, and c are not helpful numbers. They're not the slope. They are not the y-intercept. They're not even an x-intercept. They're nothing. They're just like some random numbers. And so that's super frustrating. This form here is called standard form. And it's not super great for graphing purposes, but it is great for story problem purposes, which we'll be talking about soon. However, there is kind of an easy way to graph when you are in standard form, kind of easy. What we can do is we can find our x-intercept by ignoring y and solving for x. And that's because our x-intercept always has a y value of 0. So I can essentially just block this out and then solve for x. So like I would divide both sides by a. And again, these will be numbers, not letters. So I know it's freaky right now because they're letters, but you're just going to be dividing numbers out. So that's not so bad. And whatever you get there is your x-intercept on the x-axis. Then you can kind of do the reverse of that, where I find the y-intercept. And I know that the y-intercept will always intersect the x-axis at 0. So I know that x, like I can put 0 in for x and it'll just disappear. And so we can solve for y by ignoring x and then dividing the b away. And so we'll have our y-intercept. And again, those will just be numbers. You'll have 2 dots, connect them up, you got a line, there you go. Fun fact, the slope, if you're curious, has a little mini equation using the a, b's, and c's as well. Your slope will always be negative a over b, which is just maybe a fun fact if you want to double check to make sure that your slope makes sense. So, taking all that into account, the other thing that should be in that packet in Google Classroom right now is this one here, but the way you fold it is kind of complicated. So hopefully you can kind of follow along with the examples that I'm doing, and I can show you how to fold all this later. So when we're looking at these, we want to identify what form is it trying to be, so how should I graph most efficiently? So with this first one here, I initially didn't think it kind of looked like anything, but with the parentheses, that's hinting to me that it might be this point slope form over here. It's just a little off because that y needs to be alone, but I can pretty quickly add the 4 over, and we'll have y equals negative 2, parenthesis x plus 3 plus 4. And again, like you could fully distribute combine like terms and then you'd just be y equals mx plus b. But I could also stop right now and save myself some time and just think, okay, when I'm in point slope form like this, I'm first going to plot a point. The point comes from the last 2 numbers, except for inside number has to change signs. So negative 3, comma 4. The second thing that we need to do is get our slope, which is negative 2. And I always like to think of slope as a fraction, and I can always make it a fraction by just throwing it over 1. Okay, so we would go plot our, oh, Siri's listening to me. It's awkward. Plot our point, and then do our slope of down 2 over 1, positively 1. And you can do as many as you want or as few as you want. And there you go. The next one, this one here is in standard form. And guys, I think I'm going to have to pause the video for a second. I'll be right back.